up, pal? All right, so here it is. So if you have u dv, you're like, what does that mean, Grim? I got you. Hang on. This will be the integral of uv minus the integral of v du. Now, what does that do for me? Well, you'll see momentarily. Okay? Now, so what we're going to have to do on this problem is we're going to have to figure this out. One of these functions, either in our case x, either he's u and e to the x is dv, or vice versa. Okay, now listen, is there a better way to do it? Yeah. Are you going to let us in on the secret? Yes. Okay. Now, which is easier to do? Take derivatives or take integrals? Derivatives, and it's not close, yes? So we are going to have an order in which to select our u's, and it goes like this. Li, a, te. If you have a choice for who you should be for your u, you should start off with logarithms. They are a bear to integrate. Therefore, I'm not going to. I'm going to take the derivative instead. Really? The next thing that comes along are inverse trig functions. They are also a bear. So I'd rather take the derivative of them. Then algebraic functions. Do you mean like x squared? Sure. Etc., etc. Yeah, etc. Yeah. 2x plus 5. Sure. What about t's? T is trig, baby. And lastly, but not leastly, what is e? E! Why? Because anybody can integrate e, yes? So it would be my last choice to make my u, yes? Does that make sense? Because whatever I pick to be dv, I'm going to have to integrate. You with me? And I don't want to. Okay. But if I choose e to be that fella, hey, what's the integral of e to the x? Oh, it's e to the x! Yay! So I ask you, friends, which of these fellas should be u and which should be dv? Well, u, or x rather, is an algebraic function. It is higher on the list of this should be my v, then, it's who should be my u rather, than e, yes? So I'm going to let u be equal to x, and I'm going to let dv be equal to e to the x dx. I forgot to tell Levi his car is done. Okay. All right, now, so here's the game. Let's follow the recipe. So the integral of x e to the x dx is equal to u times v. But Groom, I don't know what v is. Neither do I. Oh, yes, I do. It's e to the x. Thank you.
I just put it right here. There's no rows.
Perfect. He'll be here in a minute to get it. Well, I don't know, half an hour. I don't know when he's coming. Soon-ish, I think. Yeah, perfect. Okay, so here we have it. And then what would du be, friends? Just 1 dx or just dx, right? So the formula says we're going to take x e to the x, that's uv, minus the integral of e to the x dx. We're not done yet. We just followed the pattern. Do you see it? So this piece just comes straight down. X e to the x minus e to the x plus c. That's it, baby. Now, so if you have this, how do I know if this is correct or not? Well, if I take the derivative of it, turns out you should it right on your tablet with a ballpoint pen. All right, let's try that again. How could I prove that this is the integral of that? How could I prove it? How could I prove it to myself? Take the derivative. Prove it to me. Let's go, baby. Let's do it. Let me know if that would work for you. Let me know if that would work for you. Thanks, Jay. Got it. Done. Sent. Too many freaking emails. I am tired of email. It turned out I don't like them anymore. So what do you find out? Anything good? What do you think? 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 Look at it. What do you think? Take the derivative. What's the derivative of this guy? Well, that's a product rule, yes? So the derivative of the first, which is 1 times the second, plus the first, times the derivative of the second. And then what's the derivative of e to the x? Hey, it's e to the x. Whoosh, whoosh.
Bam.
Bam! Magooch. Now, do you want a clipboard for that, bro? You just walk around like with a piece of paper. Oh, okay. All right, let's try another, because it's kind of fun after a while. You're like, Groom, I want another one. Okay, Kaylin, this is for you, dear. Let's take the integral of e to the x sine x. Oh, fancy. Fancy. Listen, obviously not a substitution issue, yes? None of the things that we would normally do would work here, but it's a product. So, who, I ask, should be my u? Sine x, because t becomes before e in this alphabet. E to the x dx. And so then du would be who? Cosine x dx. Well done. And of course, e to the x. I got you. For some reason, my pen's leaking, apparently. And so the formula says if you have the integral of v du, no, sorry, u dv, sorry, my bad, u dv, then the answer is v uv minus the integral of v du. So let's start plugging and chugging, baby. So it's e to the x sine x minus the integral of e to the x cosine x dx. Oh dear. Oh dear. Oh. Thank you. Now, you know how long it took Mr. Groom to figure that out the first time he saw this problem? A long time. Because I'm not the sharpest tool in the shed. But listen, you need to know when to get off the merry-go-round. We're not there yet. We're halfway around the merry-go-round. As you said, we're going around in circles, but we have not made a revolution yet. Let's keep going. So, what would I do, Groom? Well, I feel like this piece here is going to stay the same. Aight? But what we need to do is the exact same thing with new guys, yes? So u cosine x, and then dv is e to the x dx. Minus sine x dx, yes? And so now this is where it gets tricky, people. Minus parentheses. You forget the parentheses, you screw it all up. Ask me how I know. Okay? So it's going to be e to the x cos x minus the integral of v du, but that's a minus, so it's a plus. Plus, and that would be sine e to the x sine x. And now, my friends, we have made a full revolution, yes? Can you see that? Now, let me suggest to you that this is the integral of e to the x sine x dx. True that? This is the integral of that. If I distribute the negative through, that becomes a negative. this becomes a negative, yes? What do you notice it's the same on both sides? So could I plus this fella here over to there? And if I did, how many would I have? Well, I have one negative one of them. I would have two of them. No, listen, we're getting off. We are dismounting the merry-go-round right now. Dadgummit, I don't want two of them, I want one of them. So what do I do? Divide. We gone. This is stupid. Who came up with these ideas? No. Well, someone smarter than me, that's for damn sure. Because I'm not smart enough. I am not smart enough. You get rid of the legs, you just get rid of the speed, right?
Yeah, I'm trying to.
Well, I was asking. No, I think speed is just what you need. Yeah. But, you good? That makes sense? Now, this one here, you see why this one's going to be problematic? When you have X or something out front, even if you do it more than one time, eventually the X piece will go away. Yes? You get driven, gone. In the case of this fella, either the X is dying X, nothing's going away. You have to have an X string. It will always be 180, 360, now we're off. Now dismount. I didn't see him running again. I never had a problem in college. And I remember sitting there and going, oh, it's awesome. It's taking forever. And I was never getting any closer to getting done. And then the teacher goes, well, see, you can move them.
It's like cosines, like
yeah, no, I just kept going, but I didn't no one told us that you could do that. That we had, or you didn't even want it.
not infinities.
Oh, that's true. Okay. Here we go. So, here we go. Let's try another one here. Now, I'm going to stand back and watch on this one for just a jiffy. So, if you have the integral of x sine of 3x dx, try that one on for size. I don't want to do anything. I want to go home.
All periods, huh?
About, yeah. So check this out. Look at this for a second. What do you? I heard function. Hey, don't run off, Reed. I heard function and function. Yes. Why am I saying function and function? Why are you saying this? What was your thought process? Don't run off, Reed. I didn't talk to you. So who's who? X. Who's you? X is beautiful. So X is you. dx or du is dx. That's bitchin'. Now, if I have dv is sine of 3x, well, damn it. du is sine of 3x dx, and you're like, Groom, I'm going to have to do... Yeah, dv, sorry. Yes. And so, listen, so I'm going to have to do an integration by substitution over here, aren't I? Yes? From whence did sine come from? Well, it came from negative cosine, yes? And you're like, well, of course I can do this in my head, or I can actually write it out. It's going to be negative 1/3 cosine of 3x. And if you need to take the time off to the side somewhere to do substitution, go right ahead, yes? If you can do it in your head, that's cool too. Okay. Keep going. Keep going. Are we pushing it too far? Getting it too far enough? Don't all that again.
So it'd be just plus 100%. Yeah, it'd be the integral plus the integral. Not that we did.
What you get? What you get? I want to watch. Can I see? Can I help? That's right. I love that. That's the question. But now listen. Hold up. Does everybody have that? Does everybody have this? Ooh. So negative x over 3 cosine 3x minus the integral of, it's negative 1/3. That's hot. Cosine of 3x. Yes? After that first step, the x went bye-bye. And now we're left with just what kind of a function? What kind of a situation is this? What would the algorithm, as they say to do if you have a function and a function? Substitution again, yes? In other words, yes? So here, negative x over 3 cosine 3x. And then what is this? From whence did this feller come? Who is he the derivative of? I don't know. So Mr. Groom off to the side over here is going to go, let's see, if I let u equal 3x, then du would equal 3 dx. I don't have that. I only have a 1 dx. So I have a third. Now that makes plus 1/9 then, right? And then the integral of cosine of u du. And what is the antiderivative of cosine? What's the antiderivative of cosine? What? The antiderivative. From whence did cosine come? He cometh from sine. I'm still not 100% convinced this is the right answer. Let's take the derivative. Shall we? Let's do it together, shall we? What is the derivative of this? This is, again, product rule, yes? So what's the derivative of x over 3? It's negative 1/3, yes? Negative 1/3 cosine 3x. Okay? Plus negative x over 3. And what's the derivative of cosine of 3x? So it's negative sine of 3x times the derivative of the inside, which is, what's the derivative of 3x? What's the derivative of 3x? times 3. And then plus 1/9. What's the derivative of sine? No, cosine. And what's the derivative of a constant? Oh, it's constant. Oh, it's not constant. It's 0. It is a constant. It's 0. It's a specific constant. All right, Tyler, check it out, babe. Check it out. This is 1/3 here, baby. It's positive 1/3. Oh, it's negative 1/3. You see that? Yeah. Oh, the 3's kill each other off. Negative times negative is a. I'm left with x sine 3x. Is that what I started with? Hey! That's exciting. We gooch. That makes sense. You see what we're doing here? What's the matter, Tyler? Does that make sense? Yeah, I get it. Yeah, I get it. All right. Let's have a fun one. This is going to be gross. Oh, x ln x dx. I'm throwing up in my throat a little bit here.
It's 1 over.
What's the derivative?
It's
Derivative
1 over
of
x. ln of x is 1 over x.
Why? You should know that. But think about that. Why is it? The derivative, ln is doing this number, right? I need a function that has positive slopes. They're tapering off to 0. I got you.
So the formula is u dv, or is it
UV minus the integral of V du.
minus d du?
I just work here, do my little thing, but that's what they tell us. Levi's mom dropped him off too. I picked him up today for dropping his car off. I hadn't seen her in a while. Weird. It's weird. Back when he was a little kid, my kids were kids. She used to coach his basketball team, traveling team. It's funny to watch. You got it? What's the matter?
No, I don't
Jace
have
is angry.
I'm just,
Well, Jace, let's follow the rules here. Jace, do you want help or are you just thinking about it? What is going on? Who's you? Why, Ellen? Because it's the top of the Eliate, but it's because it's the hardest sucker to integrate. Yes? Oh, it's gross. Don't want to do it. That's it. Yeah. All right, got her? What you got? Hey. So this is what everyone got. So you get all right. Does the x's cancel? Yes. And if you prefer, and maybe I do, pull the half out front. Maybe I do. Maybe I don't. I don't know. What does it? I don't know. Maybe. And then what's the antiderivative of x, my friends? What's the antiderivative of x? Right? Does that make sense? Oh, poop. I don't know what happened. Oh, sorry. She died. She came back. She's back. We're gooch. Listen. Oh, cripes. Does that make sense? Now, Tyler, before you go, I am dying to know if this is the correct answer. So what am I going to do? I'm going to take a derivative. So if you're watching at home, I'm talking to future Tyler too, so just in case you're wondering. There's a Tyler that's in the room, but then there's also future Tyler who's going to watch this. Plus x squared over 2 times 1 over x minus 2x over 4, yes? You with me? You with me? This is x ln x. This is x over 2. This is x over 2, negative. Ta-da! We're done. How about that? Only took them about 3 months, but they finally did it right. How about that? We gooch here? Now listen. Is it hard? No. It just takes a little time and thought processing. Is it fun? No. It's calculus. It's not that fun. Some of it is, some of it's not. This isn't the greatest. It's fine. Now, what'll be a fun... Oh, here's a fun one. How about this guy? Let's try him on for size. What would happen if you had x squared? We'll do a nice easy one. X squared. No, we need a nice easy one first. We'll do a nice easy, a little palate cleanser, and then we'll do a hard one. What if you just wanted to do the integral of ln? This is one of those tricks that unless you've seen it, you don't see it. Do you see two functions here? I submit to you that you do. I submit to you that you have this fella. And I submit to you that you have this fella. Once you see this, you cannot unsee it. I'm sorry, we started down the rabbit hole. It's yours now. If one were to continue with this process, v, of course, would be x, and du, 1 over x, dx. Oh, we got this. So uv, x ln x, minus the integral of, well, it just ends up being dx. And what is that? What's the function in front of what is the function in front of the dx right now? 1. What's the antiderivative of 1?
1 would be x.
You good? All back together? Okay, sounds good. Thank you. Yes? Isn't that fun? Isn't that kind of fun?
It's not as fun as physics. That's all I have to say.
I'm going to pitch myself off a chair in about a minute. Okay, now this one here. This one here is kind of fun.
Are you lying?
Yes, a little bit.
X squared.
We'll do a nice easy one. We'll do a nice easy one. I want you to start down the road of this, fella, and I want you to see. Wait, what? Because there's another process. You'll see momentarily. And then I'm going to show you a shortcut for this one that a friend of mine showed me. And when I saw it, I was like, why didn't they teach me this? The other teacher at church didn't teach me.
You get. You should be X squared. Yes, the integral
Minus integral b to x to x.
minus 2 the integral of x yes. X is so it's
Jacob's backing up crap out there. Backing up crap out there. Can't find tools. Jacob packs them all outside. That's my line. Do it twice.
yeah.
Yes, you do it twice.
I love that.
It's amazing.
You know the best part about making it twice? You did the second one already. Was the first one.
Lazy or something. All right. Yeah, I gotta get with the hands on. Now
That's alright, bro.
no, I'm gonna quit teaching. It's gonna become a drug addict on the side of the road, homeless person, etc., etc. Senior awards voting. Sure. The Louis C. Abrams Award. I could choose from the entire school?
There's no cool sign there.
I don't know who I'd pick for that. I'm gonna pick her. Get another one. What you got? What do you got? You get it? Did you get it?
This one.
Tiny human. Most inspirational. Jace Graham. I voted for Jace. Most inspirational seniors. I mean, all right. I don't know.
I'm super inspirational.
You inspire me. The only thing that people will screw up on this problem most of the time is you will drop a negative sign somewhere because you have negatives inside of negative, parentheses, and so forth. That is where most people screw this up. So I feel like you have u equals x squared, dv e to the x dx, du 2x dx.
That would be so much
You're wrong. No, you're wrong.
I can't wait to see what we did wrong here.
I'm waiting to. I'm just hoping. It's,
All right. And then x squared e to the x minus 2x e to the x plus. I'll go ahead and show that step, and then you'll be yes.
Yeah.
Or if you prefer,
exactly what I wrote down.
I suppose, if one wanted to get creative.
Is anyone using this?
Nope, it's all yours.
Okay.
Brr. Yes?
Oh,
It's what nowadays. What's
please no.
No, it's integration by parts. And of course, you can always check yourself by simply taking derivatives, yes? And it's pretty simple, honestly. I'm gonna do a harder one this time. I'm gonna do a couple harder ones. What do you think? Yes? Huh? Now listen, may I suggest to you, if you have a situation like this that you know is gonna go away, may I suggest to you that if you look at this, follow this down. I got x squared, I got x, I still have x, because these are basically the same, these two are basically the same step, and then I have dx, yes? Integrate, and then I integrated that again. You with me like so, yes? And if you look at it, I matched this guy with this guy, the UV, right? And then I matched this guy with this guy again like so, didn't I? All the way down the page. So when I was a young feller teaching at this high school, second or third year I taught here, the guy Steve McAtee used to teach here told me this cute little trick. He said, if you have a situation like this that you know is going to go away, right? X squared you know is going to go away, yes? Then, or let's say it's x cubed, you know you're going to do it 3 or 4 times. What a person could do is just set it up like this. U's and dv's, if you will. And then literally, you just have a column that looks like this. You're going to have x squared. And then you start off with e to the x. The antiderivative, of course, is going to be, well, just e to the x a bunch of times, yes? And then, of course, what are you going to have here? Well, you're going to have 2x. Then you're going to have just 2. And that's it. And you run out, because what's the derivative of 2? Nada. So what you're going to end up doing is this. This times this minus this times this. Oops, what now? Come on, just a minute, Jay. Try again. This times this. There we go. Sorry, you got to start on the actual thing, not the letter U, dummy. Minus this fella plus this fella. And you literally just go x squared e to the x minus 2x e to the x plus 2 e to the x plus c, and you're done. That is what's referred to as the tabular method. Because back in the day we had cooler tricks, because we had cooler tricks. Yeah. But notice it wouldn't work very well for sine e to the x sine or something, would it? Because you're going to get off the training. You have to show those steps. No.
Not the J's.
So, but you can see, because x squared is going to go away, this would work. I wouldn't use it for x e to the x, because that's silly. That's just a one-time one and you're done. But x cubed, blah, 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 that's a lane of pain in the ass. So in this case, it would simplify your motion. So you know you do this one time.
And then you have to see.
What if it wasn't plus e? What if it was from 2 to 4? Well, you stick in 4, stick in 2, and minus them, yes? Nice. All right, here we go. What about this fella here? Oh, gross. Just yuck. Ooh. Ooh. I already did that one. I don't want to do that one. That's too much work. Yeah, let's do that guy. So the integral of the ln of x over x squared from 1 to e.
No, that's great. Hold on.
So what do we get? Who's your u? Who's your b? U is definitely ln of x because that's gross. Yeah, it is, but I'd rather write it as x to the minus 2. Makes your life easier. Was just checking you, Groom. See if you're paying attention, Groom. You got me. Now what? I'm confused. Where are we going?
Well, du is over x.
Whoa, 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 whoa. Don't we plus 1 to the exponent? So wouldn't that be x to the minus 1 divided by negative 1, which would be minus? I feel like it. Now what? Finish it up.
Now we take a nap.
Finish it up.
Which already is.
Negative ln of x. X first.
Tired.
Negative x to negative
Plus integral of x first. 1 over x. And x, so negative first is just 1 over x. So you're trying to do 1 over x. You get 1 over x third.
Oh.
X ln of x over negative ln of x
Well,
so you do the integral, you do the integral of 1 over x squared. So x to the negative second. So you have to interpolate that. So you have 1 over x. So you negative ln of x over x plus oh,
Yeah. Did you see how much the totals were on those two? Just let me know what it is. They're on the 2 receipts.
I got lost.
Did you see the receipts?
so that would equal x to the negative second.
Yeah.
And then you just figure out x to the negative 2 is already there.
So, negative 5.
It's, yeah, it'd be minus 1 over x.
So, negative 1 x over x minus x to the negative.
Negative ln of x over x minus 1 over x plus c. X to the negative first.
Yes. So you have the exact same thing. You just have it.
Now we got it solved.
Yeah.
Oh.
Yeah.
Yes.
So what did you get for an answer, friend?
We're
Give her an answer.
We're plugging in the numbers.
No. What'd you get for the antiderivative? I'm just curious what you have.
Negative x. Yeah.
Minus.
So it's negative ln of x over x minus the integral of, it's actually plus, right? X to the minus 2.
Yes.
And then you got negative ln. I'm just asking before you start playing.
X over x minus 1 over
X.
plus c.
Oh, no, plus c.
yeah.
L plus E equals
No.
ln of 1 over 1 minus 1 over 1.
So the ln of 1 minus 1.
So 0 minus 1, so it equals negative
1
1. So 1 over 1, 1 over 1 minus 1 is 0.
So the negative 1 over
Yeah. Ln of E is 1.
Ln of E is 1.
yes.
So it'd be
Negative 1 over E minus 1 over
so negative 1 over 1 is negative 1.
It's not negative 1 over 1, it's negative 1 over E
Oh, yeah.
minus 1.
Negative.
So it's just negative 1 over E minus 1 over E. So
Minus 1 over.
it's just minus 2.
Which. So ln of E would be negative 1. So
Yeah.
negative 1 over E minus negative 1 over E would be
Yes.
negative
2 over E.
Yeah.
And then
Double check.
solve for that. So negative 2 over E minus
Plus
plus you right.
1.
Something like that.
Yeah.
What would happen if a feller wanted to check this on his calculator, on his Excel, on his Excel page?
So
Could a guy do that?
probably.
Sure, right? And when you get awfully close to whatever that 2 over E is what is that? It's about 80% or 0.8 or thereabouts, probs, give or take, yes. So then 1 minus it should be about 0.2 when you got done, right? That makes sense? A guy could check himself pretty easily, right? I don't know. I just work here. Probably a common spec page, I suppose, for it. Common specs. I'm gonna say 120.
I haven't typed up right here.
140. 140.
Just double checking us the entire time. Just to make sure.
Yeah. Cool. Cool.
That was better.
Oh, look at the clock. I want to get out of here. I hate Groom's class. It's so annoying to me. Got you. I know. I feel you too. I literally every day dread being in my class with myself because I'm so boring. Every day. Literally every day. Watch this.
Not that you're
Is
boring,
it,
it's
is
the
it you're
calculus.
boring, or is it because kids just. Oh, no, wait.
Now we're angry at you.
It took this long?
Well, now we're like officially. Now we're going to declare
The
war.
first tangent over x is so.
What do you notice about this?
Argentine.
One thing.
Say it. Bam! I'm so proud. I'm so happy about you. You make me so happy. I got the hard part. What is the derivative of arctan? Oh, that's one of those goofballs. Remember? 1 over 1 plus x squared. Square.
DX.
So here we go. Here we go. So it's going to be what? X arctan minus the integral of this guy. Now, before you start crying and panicking, that isn't terrible, is it? How are you going to attack that fella? I'm not going to attack him, Groom. He's a nice person. What? Why would you say that? The bottom. Oh, you dirty hooker. du is 2x dx. I don't have 2, I just got 1. X arctan minus a half 1 over u du. What's the antiderivative of 1 over u? From whence did he come? Who is he the derivative of? ln. Nice! ln of 1 plus x squared plus c. Third period. I still got 20 minutes. I don't know. What do you think? Not horrible? It's not terrible, right?
Yeah, it's
Right.
pretty
It's just kind of, yeah. All right, here. I'm talking. Here's your assignment. And I probably will pass it out as a sheet at some point, but not today. So on page 403, we were jumping. Oh, by the way this book is set up, the person who did it was a crackhead, clearly. Because a normal human puts all the integration techniques. That's what a normal person would think. No, here's chapter 5 with 1 or 2. Chapter 6 is, let's find the volume of solids rotated around something, which is fine. We'll get to that later on. And then here's more integration stuff later on. It's ridiculous. So, yes, it's a fun time. Oh, I don't know. What are you going to do here? 7 to...
Yes, but you did.
Well, it's, what is it? 7 to
What if you said no? We don't
40... 7 to...
You need.
Every other odd. 7, 11, 15, 19, etc., 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 etc. Okay, I'm going to pause this.